Today we'll discuss ISI's MSQMS 2019 QMB paper, and the first question is find the value of this limit n tends to infinite 1 by n plus 1 upon n plus 1 plus 1 upon n plus 2 up to 1 upon 3n. Now we can write this limit as limit n tends to infinite, and then we'll express it in terms of summation. So we can write this as 1 upon n plus r, where the value of r varies from 0 to 2n. Now we can express this summation as limit n tends to infinite summation r varies from 0 to 2n 1 by n and 1 plus r by n. Now we'll replace 1 by n with dx and r by n with x. So we can write this limit as this integral dx upon 1 plus x, where x is r by n. Now when r is 0, x is 0, so lower limit is 0, and when r is 2n, value of x is 2. Now this is nothing but this is log 1 plus x from 0 to 2, which is nothing but log 3 minus log 1, and log 1 is 0. So answer to this limit is simply log 3. Now for the second part, it says show that every square matrix is uniquely expressible as a sum of a symmetric and a skew symmetric matrix. Now we know that we can write any matrix A as 1 by 2 into 2A, and we can write this as 1 by 2 A plus A transpose plus 1 by 2 into A minus A transpose. So we have expressed this matrix as sum of these two square matrices. Now we look at this first matrix, which is 1 by 2 A plus A transpose, and if we take transpose of this matrix, we can write this as 1 by 2 A transpose plus A. Now A transpose is equal to A, that means this matrix is a symmetric matrix. And for the second one, we can write this as 1 by 2 A minus A transpose, and if we take the transpose of this matrix, we can write this as 1 by 2 A transpose minus A, which is minus 1 by 2 A minus A transpose. Now when A transpose is minus A, this matrix is skew symmetric matrix. So we have expressed this matrix A as sum of a symmetric matrix and a skew symmetric matrix. Now question number 2 is, let x be a positive real number, then show that for any x, x square plus pi square plus x to the power 2 pi is always greater than or equal to x to the power pi, pi plus x pi. Now what we'll do is, from the left hand side, we'll use am and gm, taking 2 at a time. So if we take first 2, we can write x square plus pi square by 2 will be greater than or equal to under root of x square pi square, which is x pi. Now we take second and third, we can write pi square plus x to the power 2 pi upon 2 will be greater than or equal to pi into x to the power pi, and if we take first and third, we can write x square plus x to the power 2 pi by 2 will be greater than or equal to x into x to the power pi. Now if we add all of them, then on the left hand side we'll get x square plus pi square plus x to the power 2 pi, and will be greater than or equal to, now here we'll take this as x pi plus, now here we'll take x to the power pi common, then we'll get pi plus x, and this is what we need to prove in A. Now the second part is solve this differential equation. So we are given this differential equation, which is dy by dx, it is equal to x minus xy. Now we can write this as dy upon 1 minus y, and it will be equal to x dx. So we have done simple variable separation. Now we integrate this function. We can write this as log mod 1 minus y minus, and here will be x square by 2 plus c. And this is the answer to this question. Now question number 3, part A is, let x be chosen at random from the interval 0 to 1. What is the probability that greatest integer function of log 4x to the base 10 equals greatest integer function of log x base 10. Now they are equal, and suppose they are equal to some number, say r. Now when greatest integer function of x is equal to r, then x lies between r and r plus 1. So for this first part we can write this log 4x to the base 10, it will lie between r and r plus 1. Now we take anti-log, we can write 10 to the power r divided by 4, it will be less than or equal to x, and it will be less than 10 to the power r plus 1 divided by 4. And the same way we can write it for the second part. Again this log x base 10 will lie between r and r plus 1. So it will be greater than 10 to the power r but less than 10 to the power r plus 1. Now there is an AND condition between these two results. So if we take intersection of both the conditions, we'll get x should be greater than 10 to the power r, but it should be less than 10 to the power r plus 1 by 4. Now we can write 10 to the power r plus 1 by 4 as 5 by 2 into 10 to the power r. So these two greatest integer functions, they'll be equal when x lies between 10 to the power r and 5 by 2 10 to the power r. Now if we find length of this interval, say LR, then length of this interval LR will be 5 by 2 10 to the power r minus 10 to the power r, which is 3 by 2 into 10 to the power r. Now we have to find length of all such intervals for which the value of x will lie between 0 and 1. So this x, it must lie between 0 and 1. Now 10 to the power r, it is greater than 0 for all r belongs to r, and then 5 by 2 10 to the power r will be less than 1 if 10 to the power r, it is less than 0.4, that is when the value of r is less than or equal to minus 1, where r is an integer. So from these two conditions we'll get this r will take the value starting from minus 1, minus 2, minus 3 up to minus infinite. Now we need to find this required probability. Now for this probability, the sample space, it corresponds to length of this interval. So length of sample space, it is simply 1. Now we need to find our favorable length which corresponds to all these cases. So our favorable length L will correspond to this summation LR, where R varies from minus 1 to minus infinite. So it will be 3 by 2 10 to the power minus 1 plus 10 to the power minus 2 10 to the power minus 3, and this series will continue up to infinite. Now this is nothing but a GP. So it will be 3 by 2 A upon 1 minus R, which is 3 by 2 into 1 by 9, which is 1 by 6. So from geometrical probability, we can say that this required probability of this event, say A, is given by small l upon capital L, which is 1 by 6 upon 1. So this required probability is 1 by 6. Now in question 3b it says the graph of 2x square plus xy plus 3y square minus 11x minus 20y plus 40 equals 0 is an ellipse in the first quadrant of the xy plane. Let A and B be the maximum and minimum value of y by x over all the points x comma y on this ellipse. We need to find the value of A plus B. Now we are given that this is some general ellipse which lies in the first quadrant. So this is some general ellipse. Now it says we need to find maximum and minimum value of y by x. Now for any point, if we join this point to origin, we'll get this line whose slope is y by x. So this slope, it will be maximum and minimum when this line will be tangent to this ellipse. Now say this value is m1 and this value is m2. Now suppose this line is y equals mx. Now this line y equals mx, it must be tangent to this given ellipse. So for condition of tangency, we'll use quadratic method. So what we'll do is we'll eliminate y. We'll write 2x square plus x into mx plus 3 m square x square minus 11x minus 20 mx plus 40 equals 0. Now we'll take x square common. We can write 2 plus m plus 3m square into x square minus 11 plus 20m into x plus 40 equals 0, which is a quadratic equation in x. Now since these two curves, they are tangent, that means this equation should have only one real root. So the condition will be, for this equation, discriminant must be equal to 0. Now if we put d equals 0, we'll get 11 plus 20m whole square minus 4 2 plus m plus 3m square into 40 will be equal to 0, which is 121 plus 400m square plus 440m minus 320 minus 160m minus 480 m square equals 0. Now we can write this equation as 80 m square minus 280 m and plus 199 equals 0. Now there are two such tangents possible. So that means this equation will have two roots, m1 and m2. Now it says the smallest value is a and the largest value is b. So this m1 is a and then m2 is b. So we just need to find the value of a plus b, which is nothing but sum of roots m1 plus m2. And for this equation, sum of roots is minus b upon a, which is 280 upon 80, and that is 7 by 2. So the value of a plus b will be 7 by 2. Now question number 4 is, we are given this determinant of the following matrix, and if a square plus b square plus c square is 2, what is the degree of polynomial? Now suppose this determinant is equal to delta. Now what we'll do is we'll write c1 as c1 plus c2 plus c3. We can write this delta as, will be a square plus b square plus c square into x plus 1 minus 2x, and here in the second one we'll get a square plus b square plus c square x plus 1 minus 2x, and here also we'll get a square plus b square plus c square x plus 1 minus 2x, and here we'll get b square minus 1x, c square minus 1x. This is b square x plus 1, c square minus 1x, b square minus 1x, and c square x plus 1. Now it is given that a square plus b square plus c square is 2. So it will be 2x, here also will be 2x, and here also will be 2x. So this 2x will cancel in all the 3 rows of the first column. We are left with this 1, 1 and 1. Now what we will do is we will write R1 as R1 minus R2, and we will write R2 as R2 minus R3. Now we can write this delta as 0, and here it will be minus x minus 1, here it will be 0, here it is 0, here will be 1 plus x, and here will be minus x minus 1, and this is 1, b square minus 1x, and c square x plus 1. Now from this first row we'll take x plus 1 common, and from the second row also we'll take x plus 1 common. So we'll get 1 plus x whole square, and here will be 0, minus 1, 0, 0, 1 and minus 1, and this is 1, b square minus 1x, and then c square x plus 1. Now if we expand this determinant about this first column, so we'll get this value of determinant as 1 plus x square, which is a polynomial of degree 2. So degree of this polynomial fx will be 2. Now question number 4, part B is, let gx equals x to the power 6 minus x to the power 5 plus x square minus x plus 3. For all x belongs to R, we need to show that gx is greater than 0 for all x. Now we'll take this first case when x is less than 0. Now if x is less than 0, then this gx, which is x to the power 6 minus x to the power 5 plus x square minus x plus 3, x to the power 6 will be positive. Now minus and minus will be plus. This one is positive, minus minus is again plus, and then plus 3. So this gx will be greater than 0. So this gx will be positive when x is less than 0. Now we take the second case when x lies between 0 and 1. Now when x lies between 0 and 1, we can say that x to the power 6 will be less than or equal to x to the power 5 will be less than or equal to x square, will be less than or equal to x, and will be less than 3. Now we can write this gx as x to the power 6 plus x square minus x to the power 5 plus 3 minus x. Now this 3 minus x will be positive, x square minus x to the power 5 will be positive, and this x to the power 6 will be positive. So in this case also gx is greater than 0. Now we'll come to this third case when x is greater than or equal to 1. Now when x is greater than or equal to 1, then x to the power 6 will be greater than or equal to x to the power 5 will be greater than or equal to x square, and will be greater than or equal to x. Now we can write this gx as x to the power 6 minus x to the power 5 plus x square minus x, and then plus 3. Now this is greater than or equal to 0. This is also greater than or equal to 0. Now this is plus 3. So that means in this case also gx is greater than 0. That means for all x belongs to R, this gx will always be greater than 0. Now question number 5 is, evaluate this double integral, which is double integral of under root of a square b square minus b square x square minus a square y square upon a square b square plus b square x square plus a square y square into dx and dy over the positive quadrant of this ellipse, which is x square upon a square plus y square upon b square equals 1. Now what we'll do is we'll use substitution. We'll let x as ar cos theta and we'll take this y as br sin theta. Now we'll put the value of x and y in this integral. We can write this integral as this integral under root of a square b square, and here will be a square b square r square, and then sin square theta plus cos square theta will be 1, and the denominator will be a square b square plus a square b square r square, and again sin square theta plus cos square theta, it will be 1. Now we have to change this dx into dy, and for that we have to use Jacobian. We have already studied Jacobian in multivariable calculus. I'll provide the link to that video in the description below. So we can write this dx into dy as ab r dr into d theta. Now here ab square will cancel. So we'll get this integral as under root of 1 minus r square upon 1 plus r square. We'll take this ab out and then r dr into d theta, where the value of r varies from 0 to 1, and since it is in the first quadrant, value of theta will vary from 0 to pi by 2. Now we can write this integral as ab and then this integral from 0 to 1 under root of 1 minus r square upon 1 plus r square r dr into 0 to pi by 2 d theta. Now in the first one we'll take r square as t, then r dr will be t dt. So we can write this as I equals 1 by 2 ab, this is from 0 to 1 under root of 1 minus t upon 1 plus t dt, and here d theta will be theta and that will be pi by 2. So this integral will be pi by 4 ab, and then this integral from 0 to 1. Now what we'll do is we'll multiply and divide it with under root 1 minus t. So we'll get 1 minus t upon under root of 1 minus t square dt. Now we split it in two parts. We'll write this as pi by 4 ab, and then this integral from 0 to 1 dt upon under root of 1 minus t square, and then minus 0 to 1 we'll multiply with 2 and divide by 2, 2t dt upon under root of 1 minus t square. Now this is pi by 4 ab, and this is sine inverse t, and sine inverse 1 is pi by 2 and sine inverse 0 is 0. So here we'll get this value as pi by 2, and for the second part we'll get this as 1 by 2 1 minus t square to the power 1 by 2 upon 1 by 2 from 0 to 1. Now this 1 by 2 and 1 by 2 will cancel. So we'll get this as pi by 4 ab into pi by 2, and then plus, if we put t as 1 it will be 0, and if we put t as 0 it will be simply 1. So value of this integral will be pi by 4 ab into pi by 2 minus 1, and that is the answer to this question. Now question 5b is, let fx and gx are differentiable functions for x lying between 0 and 1 such that f0 is 2, g0 is 0, f1 is 6, then show that there exists C satisfying c lies between 0 and 1 and f dash c equals 2 g dash c. Now what we'll do is we'll take a function hx which is fx minus 2gx. Now the question says both fx and gx, they are differentiable functions. That means this fx and gx, they are continuous in 0, 1 and they are differentiable on open interval 0, 1. Now if we find h0 will be f0 minus 2g0, which is 2 minus 2 into, and the value of g0 is 0. So value of h0 is 2. And if we find h1, it will be f1 minus 2 g1. Now f1 is 6 minus 2 and g1 is 2. So 6 minus 4 is 2. So from here we'll get this condition that h0, it must be equal to h1. So this function hx, it satisfies all the three conditions needed for Rowley's theorem. And now we can use statement of Rowley's theorem, which is if the function is continuous and differentiable and if ha equals hb, then there exists a c in the open interval a to b such that h dash c is 0. Now h dash c will be f dash c minus 2 g dash c will be 0, and this is what we need to prove. Now question number 6 is, let xn for n equals 0, 1, 2 be a sequence of real numbers such that xn plus 1 equals lambda xn plus 1 minus lambda x n minus 1 for all n greater than or equal to 1 and for some lambda which lies between 0 and 1. Now this first part, it says show that xn equals x0 plus x1 minus x0 into this summation k varies from 0 to n minus 1 lambda minus 1 to the power k. Now from this first part we can write xn plus 1 minus xn will be lambda minus 1 xn plus 1 minus lambda x n minus 1, which we can write as lambda minus 1 into xn minus x n minus 1. Now using iteration, it will be equal to lambda minus 1 square into xn minus 1 minus xn minus 2. And if we continue like this, in the end we'll get lambda minus 1 to the power n x1 minus x0. So now we have this result that xn plus 1 minus xn will be equal to lambda minus 1 to the power n x1 minus x0. Now using this result we can write xn minus xn minus 1 will be lambda minus 1 to the power n minus 1 x1 minus x0 xn minus 1 minus xn minus 2 will be lambda minus 1 to the power n minus 2 x1 minus x0, and will continue up to x1 minus x0 and will be equal to lambda minus 1 to the power 0 x1 minus x0. Now if we add them all up here, xn minus 1 will cancel, so we'll get xn minus x0. It will be, we'll take x1 minus x0 common, and then we can write this as this summation lambda minus 1 to the power k, where the value of k varies from 0 to n minus 1. So from here we can write this xn will be x0 plus x1 minus x0, this summation k varies from 0 to n minus 1 lambda minus 1 to the power k. And this is what we need to prove in the first part. Now it says hence or otherwise show that xn converges as n tends to infinite and find the limit. Now if we take x1 and x0 and without loss of generality we'll assume that x0 is less than x1. Now we use this formula, then we can write x2 will be lambda x1 plus 1 minus lambda x0 upon lambda plus 1 minus lambda. That means x2 divides x1 and x0 in the ratio lambda is to 1 minus lambda. So this x2, it will divide x0 and x1 in the ratio lambda is to 1 minus lambda. Now if we write x3 will be lambda x2 plus 1 minus lambda x1 upon lambda plus 1 minus lambda. Now this x3, it will divide x2 and x1 in the ratio lambda is to 1 minus lambda. So this x3, it will divide x2 into x1 in the ratio lambda is to 1 minus lambda. So if we continue in this fashion, then we can say x0 will be less than x2, will be less than x4 and will be less than x3 and will be less than x1. So this sequence, it is bounded between x0 and x1. So this entire sequence is a bounded sequence. Now sequence of even terms, it is monotonic increasing, and sequence of odd terms, it will be monotonic decreasing. So both the subsequences for this sequence, they'll converge. Now suppose subsequence of even indices, it converges to L1, and suppose odd indices, it converges to L2. Now we write xn plus 1 equals lambda xn plus 1 minus lambda xn minus 1, and suppose n is even, then in that case we can write L2 equals lambda L1 plus 1 minus lambda L2, and if n is odd, we can write L1 equals lambda L2 plus 1 minus lambda L1. So from here we'll get this condition that L1 equals L2. So both the subsequences, they'll converge to this same limit L. Now we'll need to find this limit. Now we are given that xn equals x0 plus x1 minus x0. This summation k varies from 0 to n minus 1 lambda minus 1 to the power k. Now we'll take this limit n tends to infinite. Now this limit will be equal to x0 plus x1 minus x0, and then we'll have this series starting from 0. Now I'll go all the way up to infinite, and it will be lambda minus 1 to the power k, which is nothing but an infinite GP. Now we can write this as x0 plus x1 minus x0, and here for this GP, its sum will be a upon 1 minus r, which is x0 plus x1 minus x0 upon 2 minus lambda, and that is the limit of the sequence. Now question number 6, second part is show that the height of the right circular cylinder of maximum volume that can be inscribed in a given right circular cone of height h is h by 3. So we are given this right circular cone, its height is h, and suppose radius is small r. Now we have inscribed a cylinder within this cone. Now suppose this radius is capital R and this height is capital H, then we can write capital R upon small r will be equal to H minus capital H upon small h. From here we can write R upon R equals 1 minus capital H upon H, or capital H is H into 1 minus capital R by small r. Now we'll write volume of the cylinder. Volume of the cylinder will be pi R square capital H, and will be pi and then R square, and we'll put capital H as small h 1 minus R by R, or pi h R square minus R cube by R. Now if we differentiate this with respect to R, we'll get dV upon dr, and it will be equal to pi h 2r minus 3r square upon small r, and if we put it equals to 0, we'll get either r equals 0 or r equals 2r by 3. Now if we put it on the number line, this is 0 and this is 2r by 3. Now this is minus, plus and minus. So this volume will be maximum when the value of capital R is 2r by 3. Now we need to find the value of capital H. Now we know that capital H is H minus R by R. So it will be H equals H, and this is 1 minus R by R is 2 by 3, which is nothing but H by 3. So area of this right circular cylinder will be maximum when its height is H by 3. Now 7th is, we are given this determinant and we need to show that this integral from pi by 4 to pi by 2 fx dx is 1 minus 1 by root 2 minus pi by 8 minus 1 by 2 log 2. Now for this integral, what we'll do is, we'll write R3 as R3 minus R2. So this function fx will be secant x cos x secant square x plus cot x cosec square x. Here will be cos square x cosec square x, and here 1 minus cos square x will be sin square x. Cos square minus cos square is 0, and cosec square minus cosec square is also 0. Now we'll expand this determinant about this third row. Now we expand this determinant about this third row, we'll get this function fx as sin square x into cos x into cosec square x, and then minus cos square x into secant square x plus cot x into cosec square x. Now we'll multiply this sin square x inside. Now we can write this function fx as cos x minus sin square x, and then minus cos square x into cot x. Now we can write this function fx as cos x minus, now we'll multiply it by 2 and divide by 2, we'll get 2 sin square x, and 2 sin square x is 1 minus cos 2x, and here we'll write this as 1 minus sin square x cos x upon sin x. Now we'll integrate this function from pi by 4 to pi by 2 with respect to x. So we'll integrate all these functions. So for this first one, integral of cos x will be sin x from pi by 4 to pi by 2. Here it will be simply 1 by 2 dx, and there will be pi by 4 minus pi by 2. Now this is minus and minus plus 1 by 2 sin 2x by 2 from pi by 4 to pi by 2, and here if we take sin x as t, we'll get this as 1 minus t square upon t dt, and here t is sin x. When x is pi by 4, value of t is 1 by root 2, and when x is pi by 2, value of t is 1. So we'll get this integral as, now this is sin pi by 2, which is 1, and 1 minus 1 by root 2 minus 1 by 2. Pi by 2 minus pi by 4 will be simply pi by 4. Here this value will be 1 by 4, and then sin pi minus sin pi by 2, and here will be minus log t from 1 by root 2 to 1, and then plus integral of t will be t square by 2 from 1 by root 2 to 1. So we can write this integral as 1 minus 1 by root 2 minus pi by 8. Now sin pi is 0 and sin pi by 2 is 1. So it will be minus 1 by 4. Now minus log 1 is 0 and minus minus plus. So it will be log 1 upon root 2, and then plus 1 by 2, 1 minus 1 by 2, which is 1 by 4. So this 1 by 4 and minus 1 by 4 will cancel. So the value of this definite integral will be 1 minus 1 by root 2 minus pi by 8 minus 1 by 2 log 2. And this is what we need to prove. Now the second part is, we are given this function fx opening upwards and gx, which is parabola opening downwards. And we need to find minimum of fx. Now minimum of fx will be given by minus d upon 4a. So it will be minus, and what's d? D in this case is 4b square minus 8c square upon 4 into 1. And for the second case, G maximum is again minus d upon 4a. So it will be minus, and then d here will be 4c square plus 4b square and 4 into minus 1. So this minus 1 and minus 1 will cancel. This 4 will also cancel. So it says minimum of fx will be greater than maximum of gx. So minimum of fx, which is minus b square plus 2c square, it is greater than maximum of gx, which is c square plus b square. So from here we can write c square will be greater than 2b square, or mod c will be greater than root 2 times mod of b, which is what we need to prove. Now question number 8 is, a piece of cheese is located at 12,10 in a coordinate plane. So we have this coordinate plane, and then we have this piece of a cheese at 12,10. Now it says a mouse is at 4, minus 2. So we have a mouse at 4, minus 2 and is running up the line y equals minus 5x plus 18. So this mouse, it runs along this line. So we put x as 4. So it will be minus 20 plus 18 minus 2. So this mouse, it is on this line. So it moves along this line. Now it says at the point AB, the mouse starts getting farther from the cheese rather than close to it. So if we look at distance of this mouse from this cheese, it is given by this distance. Now this distance will be minimum when it is this perpendicular distance. So we need to find coordinates of this point when the line joining this mouse and cheese, it is perpendicular to this given line. And suppose this point is A comma B, which is nothing but foot of perpendicular. Now equation of this line is 5x plus y minus 18 equals 0. Now we can use formula for foot of perpendicular. It is given by a minus 12 upon 5 will be equal to b minus 10 upon 1 and will be minus, we'll put the value of this point in this line. So 12 into 5 will be 60 plus 10 minus 18 upon a square plus b square. So it will be 25 plus 1, 26. We'll get a minus 12 upon 5 will be equal to b minus 10 and this value will be equal to 70 minus 18, which is 52. Now 52 upon 26 is 2. So we'll get a equals 12 minus 10 and we'll get b equals 8. So this coordinate will be given by 2, 8. So this mouse will be closest to the cheese when it is at 2, 8, and if it goes away from it, again this distance will increase. Now we need to find the value of a plus b. So this is a and this is b. Value of a plus b is 10. Now question number 8 part B is, it says we are given that log 1 plus x square plus y square will be less than or equal to 1 plus log x plus y. Now we can write log 1 plus x square plus y square will be less than or equal to log 10 x plus y. Now since base is greater than 1, we can cancel log with log. So we can write 1 plus x square plus y square will be less than or equal to 10x plus 10y, which represents the region inside this circle, which is x square plus y square minus 10x minus 10y plus 1 equals 0. Now center of this circle will be at 5, 5 and its radius will be under root of 25 plus 25 minus 1, there will be 7. So this area representing this S1 is area of this entire circle. So area of S1 will be simply pi and r square, and r in this case is 7, so it will be simply 49 pi. Now we'll come to S2. Now for S2 we are given that log 2 plus x square plus y square will be less than or equal to 2 plus log x plus y. Now we can write this as log 2 plus x square plus y square will be less than or equal to log 100x plus y. Now again we can cancel this log 10 with log 10. So we'll get area inside this circle, which is x square plus y square minus 100x minus 100y plus 2 equals 0. Now for this circle, center is at 50, 50, and its radius will be under root of 2500 plus 2500. There will be 5000 minus 2, and it will be 7 times under root of 102, which is area of S2 will be pi and then r square, and r square in this case is 4998. We need to find ratio of area of S2 to area of S1. So this ratio will be pi into 4998 upon pi into 49. This pi and pi will cancel, and it will be simply 102. So ratio of area of S2 to area of S1 is 1022 to 1.